Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this village cone problem of GFG. So guys, let's move on to the problem. Okay, guys. So here we are given a graph type structure, means here these are uh, 2D matrix given to us 1 and 3, like here 1 and 3 given to us, then it means 1 will admire 3. Okay, now what if we are given unions, okay, and union X admire Y, then Y think highly of himself but does not admire back. Okay, means X admire G but Y will not admire X. Okay, so and if X admire Y, then if Y have as many children as possible, X will admire all of them as well. Okay, X will means X admire 3, X admire all of its children. Okay, so this is now what we have to do, we have to given the dress to one, some dress will be to one, some to three, some to these children, but one condition for what we want is X and Y should not contain same dress if X admire Y. Okay, two minions X and Y will cannot wear same dress if X admire Y. So here this is X, this is Y, this is children of Y. So if X wear green, Y wear purple, then C and Y either wear purple, they neither wear green. Okay, these two dress they cannot wear because purple is wear by one of its admire, because these all are the admire of these our children admire by Y, and green is wear by X, and X also admires children of Y. So all the remaining colors, any colors like pink can be wear by them, but except green, blue. Now if suppose if his particular minions have some more admire X, okay, his is CX CY dash admire, it admire A. Now A cannot wear the dress of color pink, of color blue, of color green. So it can wear red, yellow, orange, black, white, but cannot wear green, blue, pink. Okay, this is how we have to do. Okay, and we have to find out the maximum number of dress we need. Okay, here the minimum number of different color. Okay, means the at most number of dress we need to buy so that each one can wear the dresses, like. So guys, what we have to do, we have to find out the longest chain in our graph. This will become a graph structure, like X will admire this, these have children, these have further children, these have further children, till some level. Okay guys, now the longest chain in our graph will be our answer. There is X, there is some Y, Z, A, B, C. Suppose this is the longest chain having 1 2 3 4 5 6 nodes, means his chain will require total 6 number of dresses. Now all other chains, means all other the chain we wear X admire Y, like here is one more chain, it is one more chain, like here X dash, it admire Y dash, now C dash. Okay, these are some of length 3, this is of length 2, of length 5. So this 5 length chain require 5 dress, this require 2, this require 3. So maximum number of dress we need is 6. So you guys understand till now, I hope, that we have to do BFS here, but how we will do it. So let's move on to the problem. So here we are given n, the total number of minions, and m, the edges between the minions. So first of all we have to make out the graph. So how we will make out it? Copy. Yes. So guys, what we will do? First of all, 1 admire 3, 1 admire 3, 2 admire 3, and now 2 also admire 3, 1 admire 4, 3 admire 4, and 2 admire 5, 3 admire 5, 3 admire 5. So the longest chain in our matrix is of length. How many length it is? 2. Okay. The longest chain 1 2 1 2. Yeah, it is of length 2. So but here if we put out, if we given, if we take true, no, maximum length is of 3 by 3. If we take his path, if we take, if we take his path, then one node, second node, third node. If we take his path, one node, second node, third node. If we take this path, first, second, third. So longest chain is of length 3. So maximum number of minimum number of dashes we need is at least 3. Okay. So this is how it will look like. So guys, what we will find out the in degree. In degree means the number of edges come to a particular node. Here all the edges are going to out are going outside from one. So it has in degree 0. It has in degree 0. Now for 4 has in degree means number of edges come in 4. It is 2. Now for 3 it is 1 2, it is 2. For 2 it is 0. For 5 it is 1 and 2. So now we will maintain a queue. We will, first of all we will make this graph. Okay, this graph, like from edges we will convert, like all the current neighbor of 1 are 3 and 4. So it will contain 3 4. 2 will contain 3 and 5. 3 will contain 4 5, and 4 and 5 are empty because out degree of means no one edge come out from the 4 and 5. Okay, this is what we are doing here. What we are doing here, adjacent matrix we are form of size n plus 1 because our maximum number of edge is n. So n plus 1 for each edge is 0 to m minus 1. Mat matrix is given to us, mat I0 dot goes back mat I1. Okay, now we will make a in degree, and for all the, now one guys, we can do one more thing. This is just for simplicity. Now what we are doing, for checking the in degree, what we can do, the number of times we are come to 4, we can increment its in degree. We are just maintaining a vector of size n plus 1 means from index 0 1 2 3 4 and 5. Initially everything contains 0. We are come 1 to 4. The node to which we are coming is 4. So we will increment 4 to 1. Now when we are come to 1 3, increment 3 1. 2 to 3, increment 3 to 2. Increment come to 5. From 2 to 5, we are taken 1 4. We are taken 1 3. We are taken 2 3. Now we are taken 2 5, increment 5. We are taken 3 5, increment 5 to 2. Increment 3 4, increment 4 to 2. Now these will remain 0. Okay, this is how our in degree graph will look like. This is just for simplicity. As well, what you can do, what we can do, in degree mat I plus plus. Okay, we don't need to run another loop. This is just for simplicity I write. Okay guys, now we are maintaining a queue. In queue we will put in queue we will put all the nodes who have in degree 0. Like here initially we will put 1 and 2. Initially we will put 1 and 2. So our answer should be 3. I hope you understand. So okay, because initially we will put suppose 1 and 2. Now we will take 1, we will take a variable current level. Current level means the number of grass in our current level. Initially we will make it 0. We take, then we are just doing BFS. We are taking current level 0. While q dot size means while our queue is not empty, we will take a variable q size, put q dot size in it, increment our current level. Means we found a node for which we require one more dress. We require one more dress. Now till for all the nodes at my particular level, like my first level is 1 and 2, both have same in degree. Now what I will do, I will push out, like first of all I will take one, then push back, pop out one from my queue. Then all the neighboring nodes of my C means my one, I will decrease its in degree, like for 1, 1 to 3, I will decrease its in degree to 1, 1 to 4, its degree to 1, like then I am taken 2, current will increase to 1, taken to 2, decrease its degree to 0. And if this is decreased to 0, what I will do, I will push back now 3 in my queue, means I come out one more nodes whose in degree became 0. Okay, whose in degree means to whom I need to allocate a new dress now. I allocate a dress 1 and 2 of number 1. Now for 3 I became in degree 0. So I need to give a new dress code to 3. Now 2 to 5 it will become 1. Now 1 to complete, now we are at 2 in degree update. These all remain 0, 3 became 1, 4 became 1, 5 became 1, 1, 1, 0, 1. Okay guys, so this is how we are doing. And if I will decrease in degree of all the nodes, in degree became 0, means I need to give the new address to particular IT node. I will push back IT in my queue. Now again I run a loop for this. Now for 3 I will push back I will push pop out 3 now. Now for all the in degree of increase my current level to 2, increase my current level to 2 means now I am giving the address of number 2. Now 1 will go dress with number 1, 3 will go with the dress with number 2. Now okay, now we are pop out 3, and for all the in degree of 3, now 3 to 4 it will become 0, 3 to 5 it will become 0. Now it became 0, I will pop out 4, push out in my queue. I will take out 5, push out 5 in my current node. Now I am complete my performing the operation, increment my current dress code to 3, means in 4 I will put out give the dress of code to 5. I will give the dress code 3 to each. To 1 I go give the dress code 1, to 3 I go give the dress code 2. Now increment 3, now I will take out 4, and there is no nodes of our 4 whose parent is 4 or whose admirer is 4. Similarly with 5, so our queue is empty. Now we will come out of the loop and return cur level, means we will return 3. Now you see, if we take 3 dress, then it is never possible that admirer of a particular minion y have same dress as its admirer. Okay, now here you can see 3 is 1 is admirer of 3, both have different dress. 3 is admirer of 5, both have different dress. Now 3 is admirer of 5 and 1 is admirer of 3, so 1 and 5 also have different dress. Similarly for 2 and 3, both have different dress. 3 and 4, now 2 and 4 as well have different dress. 1 and 4 have different dress with code 1 and 3. 2 and 5 have different dress. Okay, this is how we need. Answer is 3, or I already told you the maximum length in the maximum node length in our graph will be our answer, that is 3. So this is how we will find out the maximum length. Okay guys, so I'm just compiling it. Okay, answer is 3 correct. I just read the question statement wrong, that's why it will take me some time to do it. So you can see all the test cases pass out. I hope you will understand the approach. Meanwhile, you can subscribe the channel, like the video, and if you have any doubt, then just comment out. I will try my best to explain you. Please, if you like the content, then subscribe the channel, press the ring button, bell button. Okay guys, please subscribe, like, share. Thank you for watching this guys.